What is the value of area, S? Geometric theorem, line constructions, Pythagoras. Theorem, basic arithmetic and algebraic processes are used to solve this question. Draw a complete semicircle showing the yellow inscribed right triangle. Label points A, B, C and D. Locate the center of the semicircle, O. Point D equals 90 degrees. Join line AC. Let angle ACD be equals to theta. From triangle ACD. Using Pythagoras theorem. The square of line AC equals the sum of the square of line AD and the square of line CD, which equals the square of 24 plus the square of 7. The result is equals to 625. Take the square root of the equation. This implies that line AC equals the square root of 625, which equals to 25. Also, line CD divided by line AC equals cosine theta, which equals to 7 divided by 25. We call it equation 1. Triangle ACB is an isosceles triangle. It follows that line AC equals line BC, which equals to 25. Also, angle ACB equals 180 degrees minus theta, since angle BCD equals 180 degrees. Sum of angles in a straight line equals 180 degrees. Line AB equals 2 times r, where r equals radius of the semicircle. Using cosine rule, the square of line AB equals the sum of the square of line AC and the square of line BC minus 2 times the product of line AC and line BC times cosine theta. Substitute values. We have that the square of 2 times r equals 4 times the square of r, which equals 2 times the product of the square of 25 and 1 minus cosine 180 degrees minus theta. We call it equation 2. By trigonometric identity, cosine 180 degrees minus theta equals negative cosine theta. Substitute into equation 2. This implies that for multiply by the square of r equals 2 times the square of 25 multiply by 1 plus cosine theta. Substitute equation 1 into above equation and divided the equation by 4. It implies that the square of r equals 400. After simplification of substituted values. Take the square root of the equation. R equals the square root of 400, which equals to 20. Consider triangle AOC. By Pythagoras theorem, the square of line AC equals the sum of the square of line OA and the square of line OC. Substitute values. We have that the square of 25 equals the sum of the square of 20 and the square of line OC. This implies that the square of line OC equals the square of 25 minus the square of 20, which equals to 225. Take the square root of the equation. This implies that line OC equals the square root of 225, which equals to 15. Hence, area, S of the portion of the yellow triangle equals the sum of the area of triangle ACD and the area of triangle AOC, which equals to the sum of half of 24 times 7 and half of 20 times 15, which equals to 234. Therefore, the required area, S equals 234 square units.